Okay, welcome everyone. This lesson, we're going to be sort of summarizing and summing up everything we've covered so far. So, for whatever reason, we've been covering some of the harder parts of this topic first. So, we're just going to take a little moment in this lesson just to go back through all these different concepts and make sure that we know what's going on. Okay, so the very first thing we covered was actually quite simple. It's just what is a polygon? Here below you can see there's four different things that I've drawn, only one of which happens to be a polygon, and hopefully you guys know it is the first one. Why is the second one not considered a polygon? Well, it is because it has the curved side. Polygons only have straight edges. Why would the next one along not be considered a polygon either? And it is because it has the gap. Polygons do not have any gaps in them. They're like a completed, closed off shape. And why would the third one not be considered a polygon? And yeah, it's because it is 3D. Polygons are only two-dimensional shapes, so that's why the first one is the only polygon on this page. Now, one of the next things we covered was classifying triangles. So triangles are all the three-sided polygons. So if we go back to this polygon here, this had 1, 2, 3, 4, 5, 6. We had a hexagon there. If a polygon has only three sides, we call it a triangle. And you are required to be able to classify triangles. So if we look at this first triangle, it's a bit hard to see from the diagram, but it should have had dashes there and there. And while I'm at it, I'll fix this one up and this one as well. The first triangle, we can see all three sides are the same length, making this one equilateral. That's its first classification that we got from this first box, this top one right here. Looking at the bottom box, this first triangle would also be considered because all three angles are acute. This would also be equilateral and acute angled. The next one down. All right, so in this case, we're looking at this triangle. Go to the first box. We have two sides that are the same, which makes it an isosceles triangle. And looking at the bottom one, we have one obtuse angle in it, making this one a obtuse angled triangle. Again, remember, for it to be acute angled, every single triangle needs to be acute. If just one of the angles is right-angled, it'd be considered a right-angled triangle. And if just one of those angles is obtuse angled, it would be considered an obtuse angled triangle, which is what this second one was. And going down on the bottom one, all three sides are different, making this triangle scalene. And it happens to have a right angle in it, bottom left. So this triangle is right-angled. All right, probably the first of our tricky skills in geometry was finding a missing angle of a triangle. Now this first one isn't too bad. We've got ourselves a triangle, only one of the angles is missing. What we need to remember is that the angle sum of a triangle is 180 degrees. That is, the three angles add up to 180. Now, a lot of people have given this question, they'll just take the 70 and the 35 away from 180, right? And they'll end up getting the correct answer, like this actually does work, ends up being, what is that, 75 degrees. So that is the correct answer, and that's how they would do it. And this method here works fine for really simple questions, like this one here. But we saw it in a previous lesson. Sometimes there's more than one angle that's missing, and this method doesn't really work for that. That's why we were using the equation method. And that is, We know that the three angles add up to 180, right? That's the first thing we wrote here. So that means that the W plus the 70 plus the 35 is equal to 180 degrees. We have an equation. We go ahead and simplify the equation. There's 1W. 70 plus 35 is 105. And from here we solve the equation. We have to minus that 105. So 180, take away 105, gives you 75 degrees. And you may be thinking, this is way more effort than the method I just put up and then rubbed out. But the reason we use this method is this method here, this equation method, will work for all of the questions. The easy ones and the hard ones, this method will always work. So instead of learning different methods for different questions, we just have this one method that we'll always use and will always work. Let's look at a harder question. Actually, again, this one isn't too bad, to be honest. We have ourselves an isosceles triangle. That means, these two sides are the same length here, which also means the two base angles will also be equal. All right, so it's a triangle. That means the angle sum of a triangle is 180 degrees. How do I know that? It's just something we need to remember. The three angles of a triangle add up to 180. And so writing out our equation, this angle plus this angle plus this angle, the three angles will add up and equal 180 degrees. Now we go ahead and simplify the equation. We actually have two W's, two lots of W plus 50, which is equal to 180. And now we go ahead and solve the equation. Take away the 50, which gives us 130, and then divide the 2, which gives us 65 degrees. And that there is the value of our missing angles. This was a 65 degrees, and this one was also 65 degrees. All right, then we moved on and we learnt to do the exact same thing, but now with quadrilaterals. So quadrilaterals are the four-sided polygons. And well, how do we do it? Well, we do it the same way, right? We use this equation method. Our first job is to find what the angle sum is. Most of you will probably remember it's 360. But if you've forgotten, we have that special technique of we have four sides in this shape. So you take 2 away from it, which is 2. So you go 2 lots of 180. Right? Remember, you need to remember 180 degrees. That's what we use. So if you forget what the quadrilateral, the angle sum of the quadrilateral adds up to, no dramas, just take away 2. So you got 2 lots of 180, and that will give you the 360 degrees. Just type it in your calculator. All right, let's set up our equation. We have A plus 100 plus 105 plus 85. These four angles will add up to 360 degrees because it's a quadrilateral. We have an equation. We're going to go ahead and simplify that equation. There was one lot of A. Those three numbers add up to 290. And your final step to find what A is equal to get rid of the plus 290, we will take away 290. And we end up getting our answer. A, that angle here happened to be 70 degrees. That was the value of that missing angle. So this was our equation method being used again. Find the angle sum, set up an equation, and solve. All right, here's a harder quadrilateral. Let's check it out. We know the angle sum of a quadrilateral is 360 degrees. So if I add these four angles together, noting that those right angles are both 90 degrees. These four angles, 1, 2, 3, 4, these four angles will add up to 360. There is our equation. Simplifying it, we have 2 lots of x plus another x. We end up with 3 lots of x, 90 plus 90. Okay, so we've simplified the equation, and now it's time to solve it. Okay, so let's take away the 180. 360 take away 180 is just 180. And final step, to get the x, we now need to divide by the 3, and we get our 60 degrees. This angle over here was 60 degrees. This was 2 lots of 60, in other words, 120 degrees. All right, then we moved on and said, well, hey, triangles and quadrilaterals are great, but we're in year 9 now, right? What about all the other polygons, the pentagons, hexagons, decagons? Well, we have this equation method, and I wasn't lying when I said it works for all of them. In this case, we have 5 sides. We have ourselves a pentagon. First step is to find the angle sum. What will the 5 angles add up to? 5 take away 2. So we go 3 times 180. We get the 540 degrees. We have the angle sum. This is what the 5 angles will add up to. So now let's go ahead, add up these 5 angles. And we know that when we do add those 5 angles up, we should end up getting 540 degrees. All right, we have our equation. We simplify it. And now we solve it. So we take away the 320. And now we divide by the 2. X is 110. So we've worked out the size of these 2 angles here. Not too bad, and they actually start to get pretty fun, to be honest. These are the fun sort of part of geometry, but that was our equation method there. This was finding our angle sum. In an exam, you're looking probably 1 mark for that, 2 for this. All right, I believe, yep, this is our final part that we need to do. This one here, we've got an octagon. This happens to be what was in the final lesson, what we call a regular octagon. Regular means all sides are equal and all angles are equal. So this is the standard sort of polygons that you're used to seeing. You know, the regular pentagon, the regular hexagon, those ones that you're used to seeing, they're regular, right? All right, so how do we do this one here? Same as we have been. In this particular case, we have 8 sides. So the angle sum will be 8 take away 2, 6 times 180. When you type that into your calculator, you get 1080 degrees. So the 8 angles will add up to 1080. Because it's a regular octagon, every single angle will be equal to P, right? So you can just take the 1080 and divide it by 8, and that will give you the value of P. Or if you really wanted to write up the equation, there are 8 angles, they're all P. These are P's. So we have for our equation 8 lots of P, which is equal to 1080. To find P, you then divide by 8. And when you do that, I think you get 135 degrees. All right, so make sure if you're able to follow through everything that's gone through this video, you're pretty much up to date with geometry so far. So best of luck with your questions, and I'll see you next time.